Read and write binary code. Computers use the binary code in its system. It shows numbers or numeric values with a 1 or a 0, or a combination of both. Each number gets a unique representation of ones, 1, s and zeros, 0, s. The binary code is not limited to just numbers but includes the alphabet as well. Almost everything on your computer is represented by the binary code. This is the only language that the computer will recognize, so programmers must have a good understanding how things are represented by the binary code. Information, commands, or instructions that are sent over to other digital devices or computers are represented with binary code so it would make the transfer of data more efficient and exact. Since there are specific codes for everything, even color, you know if you send or share a file to another computer, it would look exactly as the original message or information. The on and off switch, for example, on a laser is controlled with binary code, so one set of binary code will turn on the laser and another set will turn off the laser. One difference between base 10 and binary. Base 10 numbers are the numbers or digits we see every day. These are the numbers that everyone knows and sees the same way. Binary code, on the other hand, represents each number with either a 1 or a 0 or a combination of 1, s and 0, s. In base 10 numbers, digits need to reach a value of 10 before it can move on to the next digit. Binary code only needs a 1 or 0 before moving on. Each number in base 10 sits in a column signifying its place in the value, ones, tens or hundreds. Binary code has columns too, but are represented and interpreted differently. 2 binary numbers. Binary code uses columns represented with 128 64 32 16 8 4 2 1. You will notice each column from the right doubles itself. So picking a number like 34 for example, and starting from the leftmost column, which is 128, you ask how many times the value 128 appears in the number 34. In this case none. So you put in a 0 under the column 128. Same question holds true for other columns, so 64 gets 0. 32 appears once in 34, so now you subtract 32 from 34, you'll get a new number which is 2 from the total. You proceed to the other columns with the new number. 16 does not appear in the number 2, nor does 8 or 4, so we put a value of 0 in each column. but it does appear once under the two columns, so we put in a value of 1 and 0 in the 1 column because from the 2 column we subtracted the number 2 from the value 2 column, giving us a total of 0. Our final binary number is 100,010. So the number 34 is represented by the binary code 100,010. Everything on your computer is represented by the binary code. All digital files are represented this way. The alphabet is also represented this way. Each letter uppercase and lowercase has a base 10 number which you use to convert to binary code. Quick tips: to check if you have the right binary code representation, take the column values with 1 underneath and add each value to see if your total is the same as the base 10 number. Useful links: American Standard Code for Information Interchange.